Hey guys, you guys should all have the handout at this point that is covering ionic bonds, and on the back side of the paper, it is going to cover covalent bonds. So we're going to talk about both of those types of bonds. Just to recap briefly, a couple of days ago, I talked to you guys about the different types of bonds, and there are really only three types. And if I'm writing, you're writing three types of bonds. There's ionic, there's covalent, co meaning to share, and there are metallic. And if you recall from when we talked about them the other day, ionic bonds form between a metal and a non-metal. Covalent bonds form between two nonmetals. And metallic bonds we don't really talk about this year. They form between two metals. So we mainly spend our time talking about ionic and covalent bonds. And the first thing that we're going to talk about today is how to write the symbol and the charge when specific things happen. And so in this case, I'm going to go over the first one of each section with you. And if you see down at the bottom, you guys have lots of extra practice down there. So put your name on your paper while we're thinking about it. So for this one, we have bromine, which is said to gain 1 electron. So you guys have to look back over at your periodic table. This one glares just a little bit, but if you guys can find bromine, it would be all the way over here. It's going to be in the dark blue to me. Some people say purple. This is in group 17. So what do we say about bromine over here? That it's got a -1 charge. So do you remember that it has a -1 charge because it has 7 valence electrons, but its real preference would be to have 8 valence electrons. So instead of having that 8, now what it's saying on this handout here is that what's going to happen, what is the charge going to be when bromine gains 1 electron? Well, bromine right now has we would write it as Br 1- charge because it has 1 extra electron. Okay, remember that it's missing, I'm sorry, did I say 1 extra electron? I meant to say that it is actually missing 1 electron. So it has 1 extra space in that outside shell. So if you were looking and writing your diagram, you would have 1, 2, 3, 4, 5, 6, 7. So this whole area right here is missing that electron, and he's pretty unhappy about it. Just for reference, in case you guys can't remember which one's the most electronegative, electronegative was a big term. Electronegative and electronegativity. This guy right here, fluorine, a couple of spaces above bromine, which is what made me think of it. Fluorine is the most electronegative element on the entire periodic table, and that means that he's the most happy to get his hands on another electron. So he's got the easiest time. The reason that fluorine would have an easier time and he's happier to get an electron than, say, bromine or iodine or astatine, you guys probably say iodine, is because the bigger that an atom gets, the bigger the space is between the nucleus and that outside shell. And so that makes them a little bit more combative, a little bit less easy to deal with because they're like the bigger atoms. The way I think of it is they're the bigger guys on the periodic table. This guy has, as between all of these right here, he's the smallest. He has the smallest radius. And there's the fewest amount of electrons between himself and the nucleus, between the outside shell and the nucleus. And remember, the outside shell is the one that's responsible for bonding with other atoms. Okay, strontium, the way that it is, where's strontium? Can you guys find strontium? Okay, good. It's number 38. Sorry, I should put it up there, shouldn't I? Strontium is all the way over here. So take a second to find it if you haven't. Strontium is number 38. It is in group 2. So that means that it wants to gain, or excuse me, it wants to donate 2 valence electrons. This guy has +1. These guys have plus 2. He says, uh-oh, I got 2 extra electrons. I would really like to unload the electrons from here and kind of drop back from this row down here really up to the row above me if I could. If in a perfect world someone asked me what I wanted to do, I would say, hey, I want to get rid of 2 electrons. And that's what he would do. Now on this piece of paper, strontium by itself has a plus 2 charge. So I say 2 plus generally, and I don't usually say positive because that doesn't mean it's got a positive charge. It means that it has extra electrons compared to its other valence shell perfect world. In a perfect world, it has 8. Well, in this real world, it doesn't have 8. He has 7 or 6 or 5 or 4. And in this perfect world, this dude has 2. Well, what's the best way to get from 2 to 8? It's not going from 2 up to 8. It's actually going backwards down towards 0. So if you look at it as like the way to get around a circle, he's not quite halfway around. So it's easier just to go back to where he started. Okay, now in this section, it says write the ion formed when bromine, which is already a -1, gains 1 electron. So if it's going to gain 1 electron, which is what he wants to do, then after that, his overall charge is going to be neutral. He's not going to have a charge. Strontium is going to lose 2 electrons, and so they're asking basically when strontium loses 2 electrons, because right now it's got a 2 plus, after that, it's just going to be strontium. So in his world, I'll just put a 0 there to help you guys remember that he just changed into everybody's perfect dream of being a noble gas, basically. He's not a noble gas. He still has all his own properties, but he became more stable in the sense that now he bonded up with whoever it was. Where did he get this 1 electron? Where did strontium get 2 electrons? They didn't just find him free floating out in the atmosphere somewhere. Somebody, meaning another element, because you know I call them people, somebody had to actually donate that electron to him. And so when we're talking about ionic bonds, it literally means I'm going to give this electron to you or I'm going to take it away from you. And because of that, somebody's going to get all charged up about it. And number 2, it says, are electrons lost or gained for the following ions? And how many are? Well, the only number you really need to know are these little numbers up here in the parentheses. I'm sorry, in the exponent area. These are not exponents. We're not going to be doing anything to the power of 3, to the -1, none of that. So it's not going to be that complicated. But you have to find rubidium on your periodic table, and I'll give y'all a second to locate rubidium. Where is rubidium hiding? Okay, so rubidium is going to be all the way over here. Some of you guys probably found it really fast because it has a +1 beside it. So it's number 37. What group is it in? It's in this group 1 over here, which is our highly reactive, I'm ready to give away my electron at any cost group. So when rubidium wants to give away its electron, what is it going to do? Even though it has a +1 charge, is it going to pick somebody up or is it going to lose somebody? And the answer is that it is going to give away. So the way to say that according to this, are they lost or gained? Technically, they're lost, even though he's very happy to lose that electron. Okay, astatine, which is, oh, sorry, that's arsenic. Arsenic is, well, I'll give y'all a second to find it. So arsenic is number 33 over here, and it's in group 7, 6, 5. So this is going to be group 5 right there. That means that arsenic has a, probably should quit writing on this periodic table. 1, 2, I really should. 3 minus charge. So that means that it is, in the sense of looking at it this way, missing 3 electrons. That means that arsenic, if you're looking only at its outside shell, has got 1, 2, 3, 4, 5 valence electrons. That means that it would love to have one here, here, and here, but it doesn't. And that's just kind of to review what that looks like to you guys because it's been a little while. So this has a -3 charge. That's why it's in group 13. It has a -3 charge. So is it going to be looking to pick up and gain electrons, or is it going to be looking to throw them away? And this one is going to be gaining. My high school teacher used to tell us that the periodic table is the hottest dating market around, and that all that they basically want to do is pick up or drop off the people that they've already dated. And so in this sense, this guy is going to be picking up some electrons. He's out there looking for somebody that has the right number of electrons for him. Well, the only people that have the right number of electrons are those that can add up in some way or another to the number 3. It could be that they have 1 electron, so you need, like, if it's hydrogen, you would need 3 hydrogens. Could be that it's got 2 electrons. Well, that doesn't quite add up to 3, so you would need maybe a beryllium that has 2 electrons, valence electrons, plus a hydrogen that would have 1. That's a total of 3. Or perhaps you could get boron. And then boron would love to bond with something like that, because 5 plus 3 is going to give you those missing 3. Okay. Using the ions in number 2, and that would be rubidium. Let me erase that so you guys can see what I did. That would be rubidium and arsenic. You have to determine which one of those is a cation and which one is an anion. Well, a cation is positive and an anion is negative. And so you would have a cation and an anion. Okay. In general, in fact, I think always, the metals are your cations. The metals are the ones with the positive charge, and they are your donors every single time. Your metals are your donors. I'm going to skip the naming part until I get back with you guys in person. But down here, what I would like for you guys to do is write the ion that is formed. This is going to be the exact same thing as you did up here from 2A and 2B. So you're going to use the same exact form as up there. So Na, is that going to be a plus or a minus? Well, sodium is going to be Na. And if you look up here on the periodic table, there is sodium. And that's going to give you a +1 because sodium has a +1 ion. If you have chlorine, it's going to bond. We're going straight across here. Chlorine is going to give you Cl. So that is all the way over here in group 17. Cl -1. What do you know about +1 and -1? They balance out to be, sorry, I'm not on the screen. Na is +1, Cl is -1. What do you know about +1 and -1? They balance out to be 0, and nature loves a 0 balance. So that formula, you don't need 1 or 2 of anything. You just have to write it like it is. NaCl. One of this, one of that. This one's going to be a little different. The K here is in group 1, so that would be a +1. Oxygen, however, is over here in group 16. And so that is going to give us, we'll write O, and then we'll write -1, -2. So this is going to be a 2-. Do those balance out to be 0? No, they don't. So how many pluses do you need? 2. So you would write K2O, because you need 2 potassiums in order to balance that out. And I'll let you guys finish the remainder of those. These down here, if it says lithium iodide, well, go back to your periodic table, find out lithium has a +1 charge, and iodine is all the way over here in group 17 with all the others that end in ine. That's going to be I, write it like a capital, by the way, and that gives you a -1. So the way that you would write that is Li, capital I. Chosen on purpose, by the way, because you guys get those little L's and I's confused. Capital L's always look like capital I's always look like that. Okay. Any other questions? And I'll address them when I get back. But your goal, your responsibility, is to finish this right here today during class.